Okay, so before I continue, I need to talk about the cross product and the dot product. So really that's just vector multiplication, and there's only two forms of vector multiplication: cross product and dot product, you know. So really what the cross product does, it gives you a vector in the end once you multiply them, you know. So really this vector in the end is going to be perpendicular to A and B. So I'll show you later which way it'll be perpendicular, because you know, if you think in 3D space, it could be two different ways, you know. So, but anyways, so now there's also the dot product. So the dot product just gives you a scalar in the end, and scalar is just a fancy word for a number, you know, just a number in the end. So, and a good example of that is mass. So with mass, you can have like just 2 kilograms. You can have, or like two slugs or something. So in the end, you're not going to have like an X, Y, Z aspect to it. It's, you know, it's just that's how much mass there is in the end. So anyways, let me erase this real quick. So really, the dot product is going to result in a number in the end. So in the end, that's why I didn't put bars around this. So really, when I put bars around my vectors, that's just saying that's the magnitude of that vector. So the main difference between the cross product and the dot product is that the cross product basically measures how much the vectors are not aligned. So I'm going to write that down right here. So not aligned. So hope I spelled that right. Oh well, this is physics, not spelling, or well, I guess math in the end too. So it's just you know, it doesn't matter. It doesn't matter. You know what I wrote down. So anyways, and then in the end, the dot product is basically showing how much vectors are aligned in the end. So in the end, it's going to be aligned. So yeah, so as you can see, this one has cosine and this one has sine. So that's the main reason why this one is how it's not aligned, and this is how it's aligned. You know, sine has opposite with it, while cosine has adjacent with it. So adjacent's more aligned, opposite's more how much is it not aligned. So as you can see, I wrote down A and B to begin with. A is just, you know, I just made up these vectors in the end, and all we're going to be doing is just doing the cross product and dot product of these two. So really, I'm going to start off with the dot product because it's just that much easier to do. So the dot product, we'll just say D. You know, D for the dot product. So the dot product, it's not a vector, it's a scalar. So D is going to equal A dotted with B. So if you want to be all fancy, make your dots huge. You know, but you know. So anyways, so really the dot product is just going to be, you multiply the x components, the y components, the z components, and you know, so on. You just multiply the components together, and then you add all those together. So really this is going to be like ax times by bx, and then plus ay times by by plus az times by bz, you know. So but yeah, so let me get rid of all that. So really it's just x's times by x's, y's times by y's, and z's times by z's, and so on, and then you just add all those up together. So yeah, so in the end it's going to be 1 times by 4, so that gives us 4 in the end, and then it's going to be, we're going to add negative 4 times by negative 2, so that gives us actually 8. And then we were going to have negative 5 times by 4, so that's going to be minus 20. So in the end, this is going to be 12 right here. 12 minus 20 gives us negative 8. So here. So in the end, I just moved that over to here. So so yeah, so I'm going to just leave some room so we can do the cross product now. So the cross product, we'll just say, is going to equal the c vector. So the c vector is just going to be A crossed with B. So so anyway, so in order to do the cross product, you're going to have to do like a determinant of a matrix in the end. So in order to set it up, it's going to be C equals, so you have these bars, so this is I, J, and then K, and then so really this is like A, and then this is B right here. So this is going to be 1, -2, -5, 4, -4, 4, and then really we're just doing the determinant of this whole thing. So if you're going to do the determinant of this, it's going to be plus and then minus and then plus. So don't forget this minus. Okay, it's very important, very important. So that's usually a problem. So before we continue, I also want to just point out, so since it's A crossed with B right here, it's going to be A's in the second row and then B's in the third row. So if you're going to do B crossed with A, then it's going to be B would be right here and A would be right here. So and really if you have B crossed with A, really that's equal to -C. So it's just the other direction. So like I said before, the cross product is really gonna, well, you're gonna have a perpendicular vector to A and B, but there's like two possibilities of that in the end with at least 3D space. So anyways, so here, let me get rid of that real quick. So anyway, so it's going to be A crossed with B. So if you're going to do that, you have to do the determinant of this. So like I said, it's going to be plus minus plus. And so if you're going to focus on the x component at first, you're going to have to block this out and then block this out. So really, it's going to be the determinant of this, and it's going to have a plus sign in the end. So let me just undo that. And so it's just the determinant of this guy. So it's going to be So it's going to be -2 times by 4. So you always go this way and then minus this way. So multiply these two minus these two multiplied together. So really in the end that's just going to be -8 and then -20. So so now we're on to the middle one, which is just the y component. So like I said before, we need to include this negative sign. So I'm just going to put the negative on the outside. So always do it like this. So a lot of times I've seen students where they just, they're like, I can just incorporate it into this number real quick, but they forget to incorporate it into the next number. They forget to distribute the whole thing. So just don't even distribute it. Just leave it out just so you can see everything. So anyways, so now we're on to the middle one. So it's going to be this and then this that we block out, and then it's just going to be 1 times by 4 minus -5 times by 4. So let me undo that. So yeah, like I said, 4, and then this is just going to be minus -20, so plus 20. So now onto the z. It's going to be block those out. This one times this one minus that one times that one. So and then I'm just gonna draw the lines here. So yeah, so in the end, so it's -4 minus -8. So -4, and then it's gonna be basically plus 8 then, minus -8. So in the end, then this is gonna equal -28. There. 28. And then this is going to be -24. And then this is just going to be, so that's just 4 in the end. So anyways, so yeah, so that's what C is equal to in the end. Okay, so before I end this video, as you can see, I just moved C up here and just erase this. So yeah, so before I end this video, I just want to show you really, like if we had A in this direction, and we had B like this, and technically this is in 3D space. So let me just draw coordinate system real quick. So you have X, Y, and then Z. So really, so it always has to be like this. You have to use the right hand rule, and this is going to be incredibly hard for me to do using showing you the right hand rule without no right hand to work with. So so really, you have to use the right hand rule to get this coordinate system set up right. But I'll talk about that later. So if you're going to do the right hand rule, really it's going to be just A crossed with B. So in the end, our angle is going to be going like this. So if it's like that, let me just get a circle up. So just need to angle it just right, you know. So basically it's going in this direction. So it's going like that. So A crossed with B. So in the end, if we use the right hand rule, we just have to do A, then so point your fingers in this direction, like all the not including your thumb, just your fingers in this direction, and then curl them in this direction. So technically, they're going to be curling in this direction all the way around. So I'm going to try to use circles as much as possible for this. It's going to be a lot easier later on, but just bear with me right now. So really curl your hand in this direction, and in the end, your thumb is going to point down this way. So really, this is the C vector in the end. So it's A crossed with B gives you C. So curl your hands in this direction. Curl your hand, right hand, not hands, right hand in this direction, and your thumb will point in C. So in the end, if we really just look at A and B, and just if we pretend we're just looking, we have 2D vectors. We'll just have this in the end, A and B. In the end, since we're going like this, C is going to point into the computer or into the board. Same thing. So in order to draw that, I'm going to draw a circle with an X. So the reason why I do that is because really to show which direction a vector is in when you're working with 2D and like that vector is in the third dimension, you have to use an arrow method. So if you had an arrow, like back in the good old days, we didn't have guns, it would be like this, you know? So if you're looking at the head of the arrow, it's going to be like this. It's going to be a circle with a dot. But if you're looking at the back end, from the back end of it, it's going to be a circle with an X, you know? So just like if this was really filled in, you know? So really if you did B crossed A, then it would be going in the other direction. So if you curl your hand in this direction, you know, like this, your thumb will point out. So it would be like this. So, but since it's A cross B for C, it's going to be into the computer. So B cross A is going to give you out of the computer. So that's basically the cross product in the end. And like I said before, I was going to show you why it has to be like this, X, Y, Z. It can't really be in any other way. So let me just erase that real quick. So you have to use the right hand rule for that even. So the right hand rule is going to show up everywhere for you guys. So so in the end, it's always going to be X crossed with Y, and your thumb will point in the Z direction. So that's just the convention for X, Y, Z coordinates. And because there has to be some convention, because you could rearrange this into be a Y and this into be a Z, and it's a completely different setup. So, but we're like physicists and engineers. You know, we have to have some sort of convention to work with. You know, otherwise it would just be way too chaotic in the end. So there's that, and then I just want to show you another thing before I end the video also. So So if you have C and it's the cross product of A and B, well then that means that C is perpendicular to B and C is perpendicular to A. So if that's the case, here, let me get rid of this also. But yeah, so if that's the case, if we do A dot with C, that should come out to 0 in the end. Just because cosine of 90 is 0, so if this is cosine, goes like this. That's 90 degrees right there. So cosine of 90 is 0. So then it doesn't matter what the magnitudes are in the end. You're just going to get 0. So I'm just going to show that real quick. So as long as I'm here, So if we do A dot with C, then we're going to get, so that's negative 28. And then it's going to be plus 48. And then minus 20. So really it's minus 48 if you just add those together, and then plus 48. So you do get 0 in the end. So which is what we expected. So it's at 90 degrees from each other. So anyways, so then if we do B dotted with C, then we should get 0 again. So, and that's if we did the cross product right, and it's looking like it is. So if we didn't get 0, then there would be serious problems. So, but anyways, so it's going to be 4 times 28. So I'm going to bust out the calculator for this. So clear. So 4 times 28. So that's 112, but it's a negative because it's negative 28. And then we have negative 4 times negative 24. So that's 4 times by 24. So then we get positive 96, and then plus, and then 16. So really, when we add all this up together, we get negative 112 plus 96 plus 16, and that's 0. So really, we get that's equal to 0. So like we suspected, this is 0, this is 0. So we definitely did the cross product right.